Hi, my name is P.R. Mukund. I'm a professor at RIT in Rochester, New York. I've been in the field of microelectronics for about 30 years and the field of electronics for almost 40 years. And oftentimes, people, when they meet me, think that because of what I do professionally, they tend to classify people like me into this nerdy world where we don't understand anything beyond the computer and beyond the electronics and so on. I want to prove to you today that that's not true, actually. And not only that, I want to prove to you that microelectronics is a very, very good forum, actually, to study problems that face us in our own lives. And not only that, the problems that are there in the world, for example, people talk about climate change, people talk about water resources and thermal management, all these things. What people don't understand is that for a person to be a really good microelectronics engineer, you do the same thing, except you do it at a very small scale. That's all. For example, if you look at this planet, for example, we have, 7 billion people, something like that today. And yet you don't see too many tall figures, so to speak, figuratively speaking. You go back 60, 70 years, there were the Einsteins of this world, the Mahatma Gandhis of this world, and so on. Today you see a lot of people all over the place, but you don't see these giants come out of these large numbers. You know what? Computer chips are like that too. If you went back 30, 40 years ago, the transistors were big. There were not that many, but they did a lot of things, right? Today, they're extremely small. So you can give me like 1 inch by 1 inch piece of silicon, and you find like, I can put hundreds of millions of transistors there. But these transistors are really small. They're not as good as they used to be. They're pretty bad, actually. So now the question is, you have this extremely large numbers of very small and not that great devices. The question is, how do you connect them? How do you still make them do something useful? How do you manage the complexity when you connect so many things? And when you do that, the same problems that we are facing in the planet, we are facing at this level as well. So you can use this forum, if you will, a platform, to study problems and actually find solutions to much, much bigger problems that face us in life. So what I want to do today is just want to take one tiny, tiny example. So after all, in this whole universe, if I can keep shrinking down the circle in which I exist, from the planet to the country to the city to where I am and so on, if I keep going down, at the lowest level is just me, right? So the question is, what do I do, in the sense that if I'm going to put some effort into doing something in my life, obviously I'd like to see maximal results. Who doesn't, right? You put some results, you want to get as much results as possible. Yet we find that sometimes I put in a lot of effort, the results are not that great. Sometimes I put a lot of efforts and there are no results at all. And sometimes for a relatively small amount of effort, I get a lot of results. The question is, can I make some sense out of all this? Can I really understand why this is happening? And can I use microelectronics to study this problem and actually not only study the problem, but actually find a solution, right? Now, in the world of microelectronics, if you keep going down, 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 at the heart of it all is this lonely little transistor. So I want to show you first what a transistor looks like, right? Not physically, but how it operates, what it does. And then I'll look at me and say, how do I operate? And is there a relationship between these two things? And therefore, if I can look at how the transistor works, I understand that very well, and I can make it do a lot of things, even though it's very tiny, and it's embedded in the universe of hundreds of millions of them floating around. Can I use the same results here so that I can maximize my benefits or the results for my efforts, right? So does it make sense? OK, so let's go. Let's start with the transistor, right? This is a symbol. For those of you who work in the field of electronics, straight away you'll know what I'm referring to. A transistor is represented by this symbol. It's just a symbol, right? So we have 3 connections to it. there is something called the drain, something called the source, and there is something called the gate. And as the name suggests, the gate actually holds the key to what happens between the drain and the source, right? So let us say I take my source and put it on ground, so to speak, right? That's a symbol for ground. So it's a reference point is all it is, right? Now, the question is, if I were to increase the potential or the voltage on the drain, you would think that if some current, which I'll call I, if some current is going to flow here, if I keep increasing the potential or the voltage at this point, you would think that that current would keep increasing, right? That's what you think. Now, to start with, let us say I don't do anything with this gate, right? And I put 0 volts here. In other words, I don't put any potential. There's no potential there at all. Then I take this, I connect it to a battery, and let's say I can vary that. So I keep changing that battery voltage, and I measure this current. I find nothing is happening. No current is flowing at all, right? So you say, interesting. So let me go here and see if this has any effect on that, right? So I connect another battery here. Let's not make it 0. Let's say I connect another battery here. I make that also variable. So I change it a little bit. I apply a small voltage on the gate, which we will call V sub G, and see whether for a given voltage here, does any current flow. And initially, I notice that nothing happens. So I keep cranking this up, and all of a sudden I find, hey, wait, there's current flowing here, right? So if I were to plot this thing, make a graph, right? So let's say I were to graph the voltage here, which we will call V sub D. This is the voltage on the drain, right? So we'll call this V sub D. This is the current. We'll call that I. And for a given, obviously, for every different voltage that I apply here, I should get something different, right? So I notice that when this V sub G is a particular value, right? Slowly, I notice that current starts flowing like this. Starts flowing a little bit, right? That voltage here, where it just barely starts flowing, is what we call the threshold voltage V sub T. So what that means is this, for this device, for anything to happen here, for any current to flow, any energy to flow through this device, it's very important that on this gate, I have a voltage that is equal to or greater than this. So that's the requirement, right? So V sub G has to be equal to or greater than this thing. Then when it is V sub G, it starts going up. So remember, this is V sub D, which I didn't draw very well. So let me write this properly. This is V sub D. So if you keep increasing V sub D, remember what I'm doing. I'm changing this. I'm increasing this. So the current starts going up as I expect it to. But then something happens. I notice that after some time, it flattens out and becomes flat like this. So it doesn't matter. Beyond a particular point, I keep increasing my voltage here. That is, I keep increasing this, but no further current goes up. So, interesting. Now what can I do? Maybe increase this a little bit. So increase this some more. So let us say that this is VG1, right? So I increase it a little bit. Similar sort of thing happens, except now you get more current flowing. So something like this happens. So it goes up. Notice that the value of the current is much higher as this thing goes up compared to this value. So this is for a different voltage on the gate. This is VG2, and so on. So I can keep doing this, right? So as I keep increasing this, this is for VG3, this is for VG4, and so on. Now, let me ask you, does that have any resemblance to the way my life runs or your life runs? You look at that and your first glance would say, no way, I mean, what is that? I mean, it doesn't make any sense at all to me. Yeah, that's a transistor, but what's like that? Okay, great. And I don't know what I have to do with it. That's just the way that physical device works. I'm a human being, and what happens in my life I cannot predict so nicely and draw some graphs and so on, right? Let me show you the same thing. Okay, I'll use a different color now. So let's get rid of some of this. Now, let's say this is me. Okay? So that's me, and I'm connected, let's say, to three things, right? So on the top, I'm connected to something. Bottom, I'm connected to something. And on the side, I'm connected to something. One thing we forgot to mention is in this device, current only flows here, right? Nothing goes into the gate. Nothing goes in here. So as far as this channel is concerned, it doesn't even know that there is a voltage here. It doesn't even know this is affecting this, right? This affects that very much, but this point here doesn't know that, right? Now let's talk about me, right? Let's say I'm grounded in something. Now what do I mean by that? Well, you know, let's say I live in a particular city, I work in a particular university, whatever, right? So let's say this is RIT. This is where I teach, this is where I work. So this is where I'm grounded, okay? Now, let's say this point is the effort that I put in to anything, right? So we'll call this my effort. And the amount of things that goes through me, whatever that might be. For example, I'll give, being a professor, you know, number of students I graduate, or a number of publications I have, the amount of research money that comes in here. Those are the things that professors do. So if you measure that, let us call that as results. I'll just call it R, right? So I put in my effort, I expect a lot of results. My assumption is that I don't know that there's a third thing here not directly connected to me, right? It's there, I don't see it, because all I see is my effort, I see what goes through me, I know that this is where I work, that's all I know, right? So if I were sometimes, like I said, sometimes I can put in a lot of effort, nothing happens, sometimes I put in a little effort, whatever, you know. Question is there any relationship between my effort and my results? At first glance, it seems like there is none. And that's why people get frustrated and they say, oh, I'm putting in efforts, you know, nothing is happening, and they start complaining. They don't know what to do about it. Now here's my thing. There is a third thing here, okay? I'm going to call that UI. You say, what is UI? Well, I'm going to call it universal intelligence, okay? Now what does that mean? Well, what that means is that depending upon how big the universe you're looking at, for example, if I look at my university, the university is a system. There's a system in place, and that system has certain intelligence, right? That system intelligence actually affects the things that I do here, because I don't work in isolation. It's not like these folks who are videotaping this. If I want to do this, if I have to videotape myself, I don't know how to do that, right? So there are experts who do that. So there is a system in place, and in that system there are various components that are all connected to me, but I don't see that connection, because on a daily basis there is no direct connection, and I keep thinking that if I put in effort, I should see more results. It turns out that suppose the system, again, this could be a university. You can think of the whole universe and call it the force, or whatever you want. I don't care what words you use. But the system, let us say, is not providing you any potential, right? So you're not getting any potential. You're not blessed by the system, right? So you're not getting that potential. It doesn't matter what effort you put in, nothing is going to happen. You keep trying, nothing happens, you get frustrated. Then you say, wait a second, is there some way, because that's not me, right? So, but if at least if I recognize that there is such a thing that is affecting what is happening here, then I need to focus on this and say, can I make sure that there is a minimal threshold of this potential that is going to affect my results? Can I make that happen somehow? Now, how to make that happen is a subject for another talk on next video, but if we assume that the potential here is beyond a certain threshold, then suddenly you notice that just like this, right, you're going to begin, so this, I'm going to overlay on top of this, right? So now, this, instead of voltage here, this is my effort. Right? This, instead of being a current, is actually results. Right? So when you exceed the threshold in the potential that you have from the system, from the universe in which you exist, you notice that when you put in effort, actually you will get some result. So you keep doing that. You say, hey, this is great. It's going up. And then you notice after some time it flattens out. It doesn't matter how much effort you put in. You can keep on increasing your effort. Nothing happens. And that is what causes frustration for most of the people. So the thing is, it's important for us to recognize that the effort will have of course it has a relationship, right, on the result. It has an effect on the result. But there is a maximum point. After that maximum point, it sort of saturates. It flattens out. So if I want more, the thing to do is not keep increasing this, because that's not going to do anything. Once you've gone beyond this point, the thing to do is to go to the next level to make sure that the system or the universal intelligence provides you more potential, so that, notice here, suppose I take this point, right? This is my amount of effort. With this much universal intelligence effect, this is the amount of result I get. But if the system has more, notice that I get that much, but my effort is the same. So the trick is, yes, I need to put in effort. Of course I do. But the important thing is, what can I do to make sure that if I want to keep increasing and keep going up in this direction? So if I want to see a lot of results for my effort, the thing to do is to study this relationship and find out what is that minimum threshold, because you need to go beyond that. You need to make sure that the system is giving you at least that minimum. What can I do to make that happen in the system? And what can I do to not only increase my efforts, because I should increase my efforts, put in the effort, but along with that, what can I do to increase this so that I'm going to see more and more and more result. Now, don't you think it's the same? It's the same thing. It's the same thing. This works same as this. So I say that man, by the way, this type of transistor is what we call a MOSFET. That's the name used for it. I claim that there's no difference between the way a man works and the MOSFET works. So if you're very good at understanding this, then that can affect how you as a human being can function as well and actually be happy. Because the other thing too is, if you put millions of these things together on the same computer chip, it's all going to affect each other, going to create noise and so on. Just like we do, just like human beings. So you put like 10,000 of us in a small place, we're all going to be yelling and shouting and creating all kinds of noise. So sometimes we lose track of the meaning of what we're doing, mainly because of all these interactions. But if we can connect hundreds of thousands of these things and make it do something useful, we can put hundreds and thousands of these things and make something useful also. So that's my point. Now, in conclusion, I just want to say this, right? I don't know if you like this or not, but if you think that, yeah, that makes sense, right? I claim that microelectronics actually is a field where we can study all kinds of problems that affects us and those around us, right? Not only that, we can find solutions. Not only that, we can test it. For example, let us say that you have limited water resource, drinking clean water resource, right? You can do computer modeling and all those things, but if you look at what people have already done to take limited available resources to make computer chips work, and some places are going to be hot, some places are not going to be so hot. How do they manage all these things? And the point is that we can actually tie all this together and use this as a platform to come up with solutions for this, right? Last thing I want to say is that if you like such things, then microelectronics is the liberal arts of this century. I really believe that. Because if you understand that, we are driven by technology. Everything we do, we have smartphones, we have this, we're always constantly clicking buttons, right? But if you want to go beyond that and use the technology in meaningful ways so that it actually makes our lives better and more meaningful, not just for us, but those around us, I claim that a good understanding of the microelectronics field actually leads you to good understanding of the universe around us. If you liked it, go and actually click on that button that says like, spread it, share it with your friends, share it with those people who may be interested. Thank you.